kidneys are the renal gland. Above the renal gland is the suprarenal gland or the adrenal gland. In yellow is the adrenal cortex where we make those mineral corticoids and cortisol, and then the cholesterol type hormones. And in the center is where we make epinephrine, that's the medulla. So let's forget about that because we're looking at the kidneys. When the renal artery comes in, which is carrying about 20 to 25% of your blood flow at rest, the cardiac output, it comes in through the renal artery. That's one of the branches off the abdominal artery. Pretty thick artery for such a small organ, but it has an important function. It's going to filter the blood. It splits into two segmental arteries. So they're showing us a segmental artery here. The kidney itself has a tough fibrous capsule around it. And it's plastered to the back wall with fat in between, adipose. So the kidneys are around the level of L2. The pole of the right kidney is a little bit lower than the left because of the liver. The fat protects the kidneys from blows or being hit, as does the floating ribs. And also, it helps anchor it to the back wall. The fibrous capsule that surrounds the kidneys will not let it expand. So when blood forces through here, I kind of look at it as the kidneys kind of fold around the blood vessels. And this indentation we see on the medial surface of the kidneys, that's the renal hilum. Just like the lungs have a hilum. And when we study lymph nodes, they have a hilum. The kidneys has a hilum. What I mentioned before about the fat, if someone loses large amounts of weight, very often, not very often, I guess infrequently, the kidneys might start to droop because they're anchored to the back wall by fat, and they might fall down. That's known as ptosis of the kidney. The ureter comes out of there. When the kidney falls down, they can sometimes kink the ureter. So if someone has had a stomach stapled and now develops severe flank pain, it could be a medical emergency because the kidneys, if this lowers and this ureter gets kinked, now you can't create urine, it backs up, the kidneys will shut down. So that can kill you. The fibrous capsule's on the outside. Inside of that is the main tissue of the kidneys. The kidneys wraps around where the blood vessels go in. This is called the sinus. And it has fat, and it has these little collecting ducts for urine called calyxes. So it has this drainage system in the sinus. Beyond the sinus and in front of the capsule is the meat of the kidneys. That's known as the parenchyma. The outer parenchyma, just like in bone, the outer portion is called the cortex. Same thing with the adrenal gland. The inner portion is the medulla. So within the medulla, we're going to have these conical shaped structures that look like triangles, but in real life they're shaped like pyramids. Those are known as renal pyramids. And they're separated from each other by columns. When we have to make or to form urine, let's look at this model of the kidneys. This shows us a little bit more. Now, let me think. Okay, no, I don't want the ureter pointing up. I'd rather the ureter points down. And does that need more light? And autofocus. So here are the pyramids. Now we want to filter blood. If I use this model, that's a segmental artery, that's a segmental artery. The nephrons, the glomerulus, the renal corpuscle, where we're going to be filtering blood, is up in the cortex. These little white dots are renal corpuscles. We've got to get the blood up there to be filtered. So the renal artery comes in, it splits into segmental arteries. The segmental arteries course in between the pyramids. Here's one, here's one, here's one, here's one. Those are called interlobar arteries. So interlobar arteries are found in the medulla going in between the pyramids. Then when they reach the end of the pyramid, they arc over the pyramid. Those are called arcuate arteries. Interlobar to arcuate. Arcuate arteries send up branches that radiate through the cortex. Cortical radiant arteries. So cortical radiant arteries are these little arteries found within the cortex. They're taking blood from the renal artery, segmental arteries, interlobar, arcuate, cortical radiant. So here's an arcuate artery. Here's a cortical radiant artery. It's going to give off branches that are going to the renal corpuscle. We see one right here. Do you remember the arteriole that takes blood to the renal corpuscle? Remember, this is the one place in the body where we have an artery forming a capillary that's being drained by another artery. So, which is the artery that goes into the renal corpuscle? What was that one called? What? Anyone? We had it. You have the test on it tomorrow. The artery that goes to the renal corpuscle to be filtered, to form a glomerulus. There were two. One leaves, one comes in. What's the one that goes to it? Just like a sensory nerve. What were they called? What? Afferent. Good. So this is an afferent arteriole forming a capillary bed called the glomerulus. It's leaving as an efferent. So because you have this thick afferent, and usually the efferent is tightened up because it's an artery, you're creating hydrostatic pressure. Glomerular hydrostatic pressure is the driving force that forces the filtrate out the fenestrations and into Bowman's capsule, which is like a catcher's mitt. It catches the filtrate. And Bowman's capsule has two layers. It has a parietal layer and a visceral layer. The visceral layer has these little podocils that make slits that assure us that nothing too large is going to get out of the filtrate. We don't want to see proteins there. We don't want to see red blood cells or white blood cells. You're not too happy if you see red blood cells in your urine. Although for women sometimes when you go for urine, you might have a little red blood in there, but that can be cross-contamination if it's your menstrual cycle. It's not from your urine. So this over here is Bowman's capsule. It will direct the filtrate into the renal tubule. So in light, what's that, light green, almost greenish yellow? That first part, with all those twists and turns, what's that one called? From Bowman's capsule, you go into the what? Crickets, crickets. What are you going to? Bowman's capsule? What's the first part of the renal tubules? It's twisted, so I'll give you a hint. It's called convoluted. Which convoluted is this? No, this one's proximal. It's proximal to the glomerulus. So it's the proximal convoluted tubule. And then the proximal convoluted tubule, this is where 100% of your organic substances for your nutrient pool are reabsorbed. All the amino acids and glucose are reabsorbed here. They have the tubule cells in the proximal region have symporters that will bind sodium and then pull in glucose. Bind sodium, pull in amino acids. The only way glucose gets into the urine is if the levels are so high that it passes through here and doesn't have time to absorb all the glucose. So 65% of the filtrate winds up being absorbed here, 100% of those nutrients. And now we go down the loop of Henle. The descending loop becomes very, very thin. It has a bunch of these little protein channels called aquaporins that allows water to leak out. And as the loop goes into the medulla is very, very saturated. It's the most salty meat of the body. So the osmolarity is so high here that water is going to come out. The filtrate has the highest osmolarity at the bottom of this loop. So if a question comes up, where is the filtrate have the highest osmolarity? The bottom of the loop of Henle. Because all the way down, water was leaking out. So you got 65% of the filtrate gone here, 35, half of it is gone by the time you're at the bottom. So you might only have 17 left or so, or 18. Now you come up the loop of Henle, and it gets very thick here. The thick portion of that loop of Henle will be where there are pumps pumping out salts, ions, sodium, potassium, chloride, magnesium, calcium. They're all being pumped out of the filtrate. So the filtrate now doesn't have as many salts. It's more concentrated in urea, but its osmolarity has gone down. We don't have that much more water to absorb. But the fact that salts are being pumped out here helps water come out over here. So the currents are going in opposite directions, but they're assisting each other. Salt coming out of here helps water come out here, and as water comes out here, this becomes concentrated, easier to pump out salts. So it's known as the countercurrent of multiplication. Countercurrent going in opposite directions, and they're both assisting each other's function or multiplying their effects. So a loop diuretic, which is designed to lower blood pressure, will prevent salts from being kicked out of the ascending limb. Well, if that happens, not a lot of water will come out of the descending limb, less water. If that's the case, you wind up urinating more. And that's what a diuretic does. So Lasix blocks this loop from kicking out salts. So once you reach the top of the loop, you go into these twists and turns, which, by the way, give us more surface area to absorb and secrete things into there. So this is called the distal convoluted tubule in deep green. And a distal convoluted tubule empties into collecting ducts. And collecting ducts will receive many distal convoluted tubules and course down the center of the medulla, which is why if you put your hands against here, it feels ribbed, it's striated. There are these collecting ducts coursing down. And a bunch of collecting ducts merge into a papillary duct, and the papillary duct will empty into the minor calyx. This is a minor calyx. This is a minor calyx. This over here would be a major calyx. It's receiving urine from here, and from here. This is a minor calyx. This is a minor calyx. This is a minor calyx that's deeper in coming out. This is a major calyx. If I point to this is the renal pelvis. Major calyces all empty into the renal pelvis. The renal pelvis goes out the ureter. Losing power here?
It's your connection.
What?
It's the connection.
Really? I didn't know if it was power saver on the thing. Well, what connection?
I thought it was from
Yeah, it might be that, let me shut it off and turn it on, see if we get it to come up again better. Right. Because I don't think I had it on that long, but maybe I did.